Next is mechanical properties of fluids. Fluids are those substances which can flow, and these includes liquid and gases. So we can write fluids include number 1 liquids and number 2 gases. The properties of the fluids are number 1 shape. Fluids do not have definite shape because they attain the shape of the container in which they are placed. In terms of volume, volume of liquids is fixed, but gases occupy the volume of the container. In terms of density, density of liquids is fixed or almost constant, while density of gases changes with the pressure. If we apply pressure, then density of the gas increase. Similarly, in terms of compressibility, liquids are almost incompressible, while the gases are easily compressible. Fifth is shear stress. That is, fluids do not support shear stress. That means the force exerted by the fluid pressure must be perpendicular to the surface of containers that hold it. We can divide the study of the fluids in two groups. One is fluid statics, that is, there is no relative motion between fluid elements, and another is fluid dynamics, which we will discuss later, in which there is a relative motion between the fluid elements. So we take some properties in terms of the fluid statics. Number 1 density, generally represented by rho. So density is the ratio of mass per volume. Here we take an elementary part of fluid for which mass is delta m and its volume is delta v. So average density becomes delta m by delta v. And this density is the function of position, that means x, y, z. So density may differ from point to point. In case the homogeneous object, density will be same throughout, that means rho is constant and independent of the position. In that case, we can write rho equal to total mass by volume. In general, we will use this definition. Density is a scalar quantity. That means it has only magnitude. It do not have the direction. Its SI unit is kilogram per meter cube, and its dimensional formula is ml minus 3. For example, density of water at 4 degrees Celsius is 10 to the power 3 kilogram per meter cube. Density of water at 100 degrees Celsius is 0.998 into 10 to the power 3 kilogram per meter cube. Similarly, density of seawater is slightly higher, and it is equal to 1.03 into 10 to the power 3 kilogram per meter cube. These are some examples of the densities. Similarly, we can define specific gravity and can also known as relative density. It is the ratio of the density of substance with density of water at 4 degrees Celsius, at which it has the value 10 to the power 3 kilogram per meter cube. So we can write some example of a specific gravity. For example, number 1, water at 100 degrees Celsius will have the specific density 0.998. Similarly, mercury will have the specific gravity equal to 13.6. Let's take one problem. Question is, find the density and the specific gravity of a fluid if its 150 gram occupies 75 centimeter cube. Given mass is 150 gram, so in SI system it will be 150 into 10 to the power minus 3 kilogram. Similarly, volume is given 75 centimeter cube and it will be in SI system 75 into 10 to the power minus 6 meter cube. Density is mass per volume. So we will put the value here. And on simplifying, 150 get cancelled by 75 by 2 and it will be 2 into 10 to the power 3 kilogram per meter cube. Specific gravity is the ratio of the density with respect to the density of water at 4 degrees Celsius. And this value of the density of water at 4 degrees Celsius is 10 to the power 3 kilogram per meter cube. So specific gravity will be 2 into 10 to the power 3 divided by 10 to the power 3. So specific gravity of the fluid will be 2. This is the answer.